Have you heard what's happening in Calgary, Canada? Home to some of the world's best researchers and innovators in life sciences, Calgary is advancing healthcare solutions to solve global challenges. Calgary's dedication to the life sciences sector is evident in its labs, hospitals, schools, and the minds of its people, with its top institutions producing internationally recognized research and more than 110 life science companies backed by a highly skilled pool of talent. The life sciences sector is accelerating innovation in Calgary. If you're a bright mind or a bright company, Calgary is just the place for you. Take a closer look at calgarylifesciences.com. Before we get started this week, I wanted to tell you about the digital library from Deep Dive. How much time does your team spend looking for research papers? Google, PubMed, social media. There's got to be a better way. You can now search a reference database of 100 million scientific papers and read the full text of 20 million articles, annotate them, and share with colleagues. It's the smarter way to do research. Here's the best part. If you're like me and been frustrated by not being able to access articles you find because they're behind a paywall, I've got good news. With Deep Dive, you get one-stop affordable research. If you're a listener of the Bio Report, you can try the enterprise version of the service for free for 1 month. Go to deepdive.com/podcast and enter the code BioReport. That's Deep Dive, DeepDive.com/podcast, and the code is BioReport, one word, all caps. I'm Daniel Levine, and this is the Bio Report. Integrins are a diverse family of proteins that play an essential role in many cellular biological processes. They also have been implicated in a number of autoimmune, cardiovascular, and metabolic diseases, as well as fibrosis and cancer. While a number of biologics have come to market that target integrins, drug developers have been stymied in efforts to develop oral therapies that can target these proteins. Morphic Therapeutic is developing a new generation of oral integrin drugs it believes can transform the treatment model for a range of serious medical conditions. We spoke to Praveen Tipirneni, President and CEO of Morphic Therapeutic, about integrins, the challenges of developing small molecule therapies to target them, and why this can have a dramatic effect on how patients with a range of conditions get treated. Praveen, thanks for joining us.
Well, thank you. Thank you for inviting me.
We're going to talk about integrin proteins, their role in a range of serious medical conditions, and Morphic's efforts to bring oral alternatives to approved biologics to treat inflammatory bowel disease. Perhaps we can start with integrins. What are they and what do they do in the body?
That's an important thing to start with. Integrins, actually, why don't we start by talking about our founder? So Tim Springer is the founder of Morphic Therapeutic. And this company really is, we talk about it as a 30-year quest by Tim Springer. And the reason we say that is Tim actually, from his Harvard lab, discovered the integrin class of receptors. And this was in the early 80s, and he spent the last multiple decades really working on this integrin receptor. And the integrins are a really fundamental biology. They are cell surface receptors. They're a family of cell surface receptors with this unique ability to signal bidirectionally. And that's, when you think about integrins, the name, integrate. So they integrate outside of the cell inwards and inside the cell outwards. Yeah, so extracellular and intercellular stimuli. And they play this very central role in autoimmune, fibrotic, cardiometabolic diseases, and cancer. Just to make it a little bit tangible, something that probably everybody can relate to is and the fundamental nature of the receptor. When you think about the immune system and those leukocytes, those T cells coming from their source, which could be lymphoid tissue or other areas such as Peyer's patches, for them to get to where they need to fight the infection, the foreign body, the cancer, that's all managed by the integrin receptor, how they home to the right location, how they attach to the right cell, how they get integrated, and the transduction from the systemic circulation into the subendothelial space. All of that is managed by the integrin receptor.
You're targeting a wide range of conditions. What are the range of indications you're exploring, and what role do integrins play in these diseases?
Yeah, that's one of the interesting things about Morphic Therapeutic is that it is a platform, and we say that we are the integrin company, and so that automatically puts us into a large potential set of therapeutic indications and therapeutic areas. So if you look at our lead molecule, which is MORF-057 for inflammatory bowel disease, so that one is one where the integrin receptor plays a key part in the blocking of the T cells that are in the blood vessels into the endothelial space. So actually, let me step back for a second. Inflammatory bowel disease is a disease where the leukocytes, the T cells, are in that subendothelial space when they shouldn't be. Like if you had an infection or something, that's where they should go. But in this case, healthy folks have it, and that's what causes the pathology. And what the integrins do in that particular indication is these T cells that are in the blood vessels, in these systemic circulations, the integrins grab them, and well, I'm talking metaphorically here, but they grab them and they're responsible for pulling them into the subendothelial space. So by blocking that, you block the pathology of inflammatory bowel disease. In other areas, in actually most of our other areas, it's around the signaling cascade. So integrins are involved in fibrosis, they're involved in cardiometabolic diseases, and play various different roles really in organizing tissues and components that relate to the immune system.
There have been biologics that target integrins that have won regulatory approvals. How broadly have these been used, and how effective have they been?
Yeah, the integrins have been a very successful class to target. These were the biologics and infusions, but there are a number of blockbuster drugs that are targeting the integrins. Tysabri, for example, which is the Biogen drug for MS, that is an antibody that blocks alpha-4 beta-1, which is an integrin. And alpha-4 Entyvio, which is a drug that actually Tim discovered. It was part of his first company, Leukocyte, which was bought by Millennium, which was bought by Takeda. So it's a Takeda drug now, large drug, multi-blockbuster. That one is alpha-4 beta-7, a biologic again, an infusion that blocks that attachment of the T cell into the subendothelial space. So there's a couple of blockbusters there, but also numerous other drugs, the anticoagulants. If you and I have a heart attack today, when we go into the hospital, there's the high likelihood that you'll be getting an anti-integrin drug, the alpha-2b beta-3s, which are anticoagulants, and those are well known. And now many actually are generic. They've been around for a while, but all well-known life-saving drugs. So it's been a very attractive target class because of the fundamental nature of the biology. they've been, for biologics, we've gotten numerous drugs out of them. We haven't been able to get them for oral molecules.
Well, what's the case for developing an oral therapy to target integrins?
Yeah. So if you look at the indications that we are working on and the indications that lend themselves to, anti-integrin therapy, there are things such as autoimmune diseases, fibrosis. So let me just talk about a couple of them. So one we talked about was inflammatory bowel disease. This one is a disease that people aren't dying. So this is young people in their 20s who have a very difficult life. Abdominal pains, fibrosis. These people, when they go to a new location, they know every bathroom in the area because they can't control bowel movement. So it's a very difficult life, but they aren't actually dying. They are just having very, very difficult lives. And so an oral pill in that application where folks are traveling, they have jobs, they have kids, they lead largely lives that look very similar to ours, would be a huge advantage. And other areas such as fibrosis, again, these are chronic diseases. And for chronic diseases, people prefer oral drugs that they can take at home as opposed to things that they have to inject in them.
What are the challenges in developing small molecule approaches that can target integrins?
Yeah, there's been a lot of challenges. That's why we say it's been a 30-year quest. So, there's So the way to think about it, so the integrin receptor is a heterodimer, and that consists of an alpha pair, an alpha subset, and a dimer, and a beta dimer. And they come together to form the integrin receptor. But it's been because of that commonality between dimers there, between subunits, it's been very difficult to create specific molecules for a particular integrin. And that's really, really important in a number of different ways in terms of being able to interrogate the biology, so to understand what a particular integrin target actually does and what diseases it can affect, but then also from a therapy standpoint, being able to target the very specific receptor that you want. That just has not been possible before for small molecules. And the other part of it is that we understand a lot about the various conformations of the integrins, which we didn't back then. That's really what led to the founding of Morphic Therapeutic. That's the founding thesis, that we understand how to stabilize the various conformations. And that has a whole number of effects downstream of understanding that. And so that has been the real difficulty. And the reason why Morphic has been able to do it and nobody else has is because if you want to go after the integrin receptor in a structure-based drug discovery manner, Morphic is the only game in town. We are the only company that is able to generate the crystal structures to be able to come at the integrin class in a structure-based drug discovery manner. And that's really what's enabled us to get here.
Your lead candidate is Morph 057. It's in development for inflammatory bowel disease, which you've tapped on. This includes ulcerative colitis and Crohn's disease. For people not familiar with these conditions, how do they manifest themselves and progress?
Yes, that's a great question. Inflammatory bowel disease, it's a very interesting disease in that it's a disease of it's a disease of developed economies. So if you look at inflammatory bowel disease prevalence 100 years ago, 100 plus years ago, it really didn't exist. And as companies develop, the prevalence of inflammatory bowel disease increases. And there are two broad types, ulcerative colitis and Crohn's, and they're related, but also they have their own distinct features. But the commonalities of it, so why I say it's a function of developed economies is we don't fully understand, nobody does, what leads to inflammatory bowel disease. It is some combination of environmental factors and probably local insults in in the body, in the GI tract, but we don't fully understand that. But what we do know is that it's a disease of developed economies, but the commonality of it is that T leukocytes, the lymphocytes are in a place where they're not supposed to be, and how these diseases manifest themselves is, for example, if you think about it, this is a previously healthy person, so could be any of our kids, right, that is going to college perfectly healthy. The next year, that person could be diagnosed with inflammatory bowel disease, and what that looks like is crippling abdominal pain daily, leading to uncontrolled, episodes of going to the bathroom, leads to fissures throughout the GI tract and pain, and to a point where it is the severest manifestations are quite disabling, actually. So would prevent them from actually going to school and things like that. And so it is a very, very severe disease, and there's two types of it, ulcerative colitis and Crohn's, and they affect different areas of the GI tract. But just to keep it simple, it's very, very difficult eating, abdominal pains. It ultimately leads to fibrosis, and you have parts of your bowel removed. It leads to all kinds of uncontrolled bowel movements daily. So a very difficult disease to live with.
These are considered autoimmune conditions. Morph 057 is an alpha-4 beta-7 integrin inhibitor. What role does alpha-4 beta-7 play in the inflammatory process in these conditions?
In ulcerative colitis and Crohn's, it plays a fundamental role. And let me just try to picture it for you. So you have a blood vessel there, right? And then underneath the blood vessel, or around the blood vessel, is the tissue, right? The endothelial space, right? And so these T cells are going along in the bloodstream, and if there's no infection or any kind of insult, they should just keep going, right? And if there is some issue that comes up where these T cells are needed, they go into that tissue and control whatever the insult is. In this case, they're going in without an insult, right? And so they're there where they shouldn't be. And so what happens is, in the bloodstream, the T cells express alpha-4 beta-7. And then that attaches to its natural ligand, MAdCAM, and that's what transmigrates the T cell into that subendothelial space. And so I almost if you want to visualize it, you could think about in a lumber kind of rolling down a stream, and someone's grabbing the lumber and pulling it in. That's the lumber is the T cells. And so alpha-4 beta-7 plays a fundamental role in attaching to that cell wall and then getting transmigrated. So blocking that keeps the T cell going in the bloodstream.
So how does Morph 057 work?
So Morph 057. So what it does is it's if you think about the antibody vedolizumab, it covers. It's a big molecule, covers alpha-4 beta-7, and that prevents alpha-4 beta-7 from binding to its ligand. In this case, it's a little bit different since it's a small molecule, much smaller. So in this case, we sit, exactly, the molecule sits exactly where the ligand would attach, and so preventing that attachment into the alpha-4 beta-7 integrin.
Entyvio, which you've mentioned, is a biologic used to treat inflammatory bowel disease. It's gut selective. What's known about the selectivity of Morph 057? Is it very particular in its activity to the gut?
Yes. So the way to think about that, right, is that the antibody, for example, vedolizumab, or the small molecule, are not selective to the gut in the sense that they are in the systemic circulation, right? But what they're doing is they're blocking the alpha-4 beta-7 on that T cell wherever it is. What is gut selective is the ligand, right? So MADCAM is what alpha 4 beta 7 attaches to. That's in the gut area. So that enables the therapy to be gut selective. So the T cells would attach to MADCAM, which is in the gut area, and then be transmigrated. And here, blocking that blocks that interaction, which is selective to the gut area. But the drug itself is attaching to alpha 4 beta 7 wherever it is on the T cells in the same way that vedolizumab is.
What's known about MORF-057 from clinical studies that have been done to date?
Yeah, the great thing about MORF-057 is that it's a unique situation where you have a blockbuster drug potential, but you have very well validated biology. So in this case, because you have vedolizumab, the antibody, over 150,000, actually that was a few years ago, so well over that, have received vedolizumab. It's well understood that the vedolizumab inhibits T cell trafficking via a well-validated mechanism that we know from the clinical studies that it treats UC and Crohn's disease. And so there's a lot known about vedolizumab. And because of that, we can track surrogate markers even in early studies, such as phase 1, unlike many other therapies which would need a full phase 2 for. Now, I'm not saying that you don't need a phase 2. We'll have a phase 2, but in this case, the phase 1 allows us to predict quite well what will happen in phase 2. So what we measured in phase 1 is the receptor occupancy. So how much receptor occupancy do we have? Because we know how much vedolizumab has. So if we saturate that receptor, we know we're blocking the transmigration of the T cells into the endothelial space. And so that's what we showed in the phase 1, which you couldn't with a real novel therapeutic or novel biology. And so that's why I think we all recognized how validating those phase 1 results are, because we had vedolizumab, we understand the receptor occupancy of vedolizumab, and in this case we were able to have better results than we hoped for by being able to saturate the receptor with our alpha 4 beta 7 MORF-057. I'm greatly simplifying here, but and we can go into the details more depending on which direction you want to go. But the big picture is that we do and perform as well as vedolizumab, and we could show that in phase 1.
Well, what's the clinical path forward?
Yeah, I mean, the great thing about MORF-057, and this is something that we've talked about for years, is that the hard part of MORF-057 is the molecule itself, which we talked about with the platform, is that we knew the biology, it's UC and Crohn's trials, it's a well-worn path. What has not been made possible before is the actual molecule that has all the properties you need. And so that is where Morphic has really been unique. Our platform has enabled us, along with all the very smart people here, to be able to put all the properties that you would need into a single molecule. That's what's not been possible before. But the fortunate thing is, once you have that, it's a fairly well-worn path, because in this case, there have been many molecules that have developed ulcerative colitis and Crohn's disease drugs. And so we're, from that perspective, that part of it is well understood. What are the endpoints? What is the follow-up? What is the pathway? And so we are just embarking on that same pathway.
And do you ultimately expect to do a head-to-head?
No, not immediately. That may be something way in the future. Probably upon approval. I mean, that's not the approval pathway, and frankly, that's not exactly what the premise of the molecule actually is. Because remember, back to you are transforming people's lives when you have to go from an infusion to an oral, right? You are going from people coming in for a multi-hour infusion to young people who are skipping from the university to their classes to the tennis court to taking a pill, and that's transformational in people's lives. And so we are doing it versus placebo, and it I think we very much understand kind of where the bar is, and that's the path that we are going to take. There might be something someday, but that's not contemplated right now.
You've got powerful platform technology. It's not surprising to see partnering is an important part of your strategy. You've done deals with AbbVie and Janssen. How does partnering fit in with your business plan?
Yeah, partnering is an important part of our business plan. My background has been in business development as well, and the way we direct our discovery organization is we say follow the data. We don't say develop X drug because that's what fits best with the company. We know the science and the discovery is going to follow paths that aren't going to be directed by us, and so we tell them that here's some guardrails, but follow the science. And so in some cases those are going to be opportunities that we can take all the way to market ourselves, and those ones we will. But there's other ones, and some of these that we've talked about are very big indications and very big opportunities, and ones that big pharmaceutical companies find very attractive. And so those are ones that we naturally would partner, given just the scale of the trials and the scale of the costs to other pharmaceutical companies. And so I do think that since our platform is so broad, partnering has been and will be a part of the future. And I think we've shown we've been able to get very attractive economics even very early in our pipeline.
And is Morpho 57 partnered, or is the plan to take
Morpho 57 is not partnered. That is 100% owned by us.
And are you planning to commercialize that on your own, or are you going to seek a partner for that?
Well, right now we are focused on really achieving clinical proof of concept. And if you think about what we're looking at, this is a well-validated biology. We that has shown everything and more that we could have hoped for in phase 1. We know how to run the phase 2 trial, so that's what we're completely focused on now, and that will provide us a lot of options. But the nature of the compound, the nature of what people want to do with it, people are projecting that inflammatory bowel disease will be treated in combinations in the future. There are a number of big pharmaceutical companies who recognize how attractive this area is and have huge franchises in this area. So all that together, along with thinking about ex-US, suggests there probably is a partner sometime in the future. But right now we're just focused on getting it to past proof of concept.
In March, you completed a $245 million IPO. How are you using that money, and how far is it going to take you?
Yeah. That particular financing. So we actually had our IPO a few years ago, but that particular financing we did on the back of the clinical trial results that I shared earlier, which was the phase 1 results. It was we were quite at some level we were hoping for those results and we were anticipating them, but you never know for sure. So we were thrilled that the market and investors saw the data in the same way that we saw the data, and that enabled us to raise, like you said, on that particular financing, $250 million approximately, and that. So we have quite the dry powder available for the next few years, and so we anticipate that our burn rate and will enable us to get us past full phase 2 studies, so into 2024.
Praveen Tipirneni, President and CEO of Morphic Therapeutic. Praveen, thanks so much for your time today.
Hey, thanks so much. We really appreciated the time.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send an email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.